I'll buy a torch, I think. I'll probably call Russ if I get into this. I mean, it
sounds
seems to be the smart
Now-
thing.
Yeah.
Definitely. But now the German side in me has to come out. And usually if you put heat
You cannot
and
hide it.
materials together, no, I cannot hide it. But heat and material together, that has an impact on the properties.
Yeah.
And a trim press doesn't put any heat into the material. What's your take on that? Because I think that's a typical questions for most foundries.
That's a typical question. And I said that the statement is, well, that's too good to be true. Now prove it. So we've been proving it. Yes.
Hello and welcome to another episode of the Gold Casting podcast. Today we are 4 people in the recording and we're going to talk about a topic that is changing the industry. We've seen for years and years and years the machines got a little bit bigger, the peripherals got a little bit bigger, and all the die casting machine basically looked like the same, just a bit scaled up. And now in the exciting times with Gigacasting around, who blew the scale factor out of proportion, we're here to discuss something that also changed perception of how we see our die casting machines. That's why I'm happy to welcome Russ Dievenbach and Andy Mulroy.
Thank you. We appreciate the opportunity to be here with you to discuss this mega trend in automotive industry. So really exciting times.
It definitely is.
We know you guys, but could you give us a short overview of who you are and present yourself to reviewers?
Yeah, my name is Russ Diefenbach. I am a director of a team we call I3. So it's Insights, Innovation, and Market Intelligence. So basically, it's a customer-facing team at Hypertherm, and we go listen to customers, their pains, their challenges, their needs. We kind of aggregate that over an industry level perspective, and we help the customers solve a lot of the pains and challenges that they're experiencing.
My name is Andy Mulroy. I'm a business development manager for Hypertherm, focused in the automotive segment, more specifically on the this casting space that we're talking about here today, educating customers and bringing them up to speed on this new technology.
Yes, you already both mentioned one thing. So can you also introduce Hypertherm and what interesting technology are you working with?
We're a company called Hypertherm Associates, and Hypertherm is one subsidiary, if you will, underneath Hypertherm Associates. We're around 2,000 associates. I say associates because we're a 100% employee-owned company, which really allows us to respond and understand the customer needs and really focus on the customer as, employee associate owners. So I think it's a unique perspective that we bring. We have thousands of distributors worldwide. We have OEMs that take our plasma equipment and put them onto their machines like XY systems. We have a series of, or a lot of robotic integrators that take our plasma equipment, even our water jet equipment, and put them onto their systems to sell in the markets. As I mentioned, plasma is our core business, but we're also focused on water jet. As well as fiber laser. And that's our core focus areas, those 3, water jet, plasma, and fiber laser.
What's the size of this industry? Do you have like a key figure, like how many installations of plasma torches are there out there from you guys?
Our plasma business is split into like a light industrial, heavy industrial business, and that's usually determined by the size of the equipment, which is determined by amperage. So we have our light industrial has equipment from like a 30 amp systems, and that determines the capacity, how thick of a material you can sever, up to 125 amps. Our heavy industrial, they have between 200 amp systems up to 800 amp systems.
So they kind of needed to have a power plant and a backpack to get going.
Exactly. And they're not, throw on a backpack and go cut. These are the heavy industrial. These are large pieces of equipment for sure.
Yeah. Many installations, but where do you find them? I mean, I've been working die casting for many, many years. I haven't seen that many plasma installations. So, guys, where are you currently?
When people ask me what I do, I work in the metal fabrication industry. So anywhere that steel needs to be cut is typically going to be formed and welded. So when you look at the value stream of any manufacturing process related to steel,
Mm.
most of the time it's going to have to be cut first into some sort of shape before it's going to be bent or formed, fit up into a welding process. So, steel service centers are a good example of where a lot of our heavy equipment is flat plate and a 2D surface where there's a gantry and a torch moving around, cutting different shapes and holes out of a piece of plate using nesting software. A lot of handheld applications used in maintenance facilities. But really, anytime metal needs to be cut, plasma is going to be a process. Plasma is a technology that's been around for a long, long time. It's newer into this casting space, but plasma is not a new technology. It really kind of came around to displace oxyfuel. So if you're familiar with oxyfuel and the applications that oxyfuel is used in, just
Mm.
plasma has displaced oxyfuel in many applications. Starting first and foremost with thin gauge material, but on up to 50 millimeters and plus. Oxyfuel still has its place, but it's definitely not known for fine cutting. That's for sure.
Yeah, but
It-
I mean, Andy, you're the business developer. Now we have started to swim in the swimming pool of die casting. Hint from the coach: we launched Rio casting 50 years ago. Now we think we are breaking through. So it must be the most conservative industry on the globe. Or do you agree?
I would compare the casting industry to some of my days back in the oil and gas segment when the welding company that I was working for was introducing a new welding process, and that welding process was designed to replace stick. Stick
Yep.
welding is very archaic, very old, very traditional. People still use it, but anytime a critical application like oil and gas, where you're pumping thousands of gallons of oil and other highly explosive materials through a pipeline, you want to make sure that there is significant amount of risk mitigation. And so
Mm.
moving away to a new technology that you're unfamiliar with, somebody has to assume that risk. And I see the casting space as very similar to that. People are going with the old tried and true methods of trim presses. They've
Mm.
worked for so long. Even saw blades. Let's just call it mechanical processes in general.
Mm. Mm.
People know what mechanical processes bring to the table. They've built their production and their manufacturing facilities around those types of processes, and they accept it.
Mm.
When we bring a flame to the process, people kind of want to scratch their head a little bit and say, what is this going to do to our material? And how is this going to affect our overall manufacturing process the way we're doing it today? So I would say that what's cool about plasma is it's been around for a long time, but we're just introducing an old process into a new application. And
Mm.
I would say that your industry is very similar to many industries where quality and risk matters. And you do with what you know works well, and that's probably the way it's been for so long, not only in this industry, but probably in many, many others. But we're just introducing something that is an alternative to a new trend that's starting to take shape in your industry.
I
But
think
debating this a little bit, do you know what we have found out? We work with pretty many gigacastings in at least in planning discussions and trial casting and so forth. In the beginning, everybody was asking about real casting to get the properties out and reduce the porosity for either the welding or the riveting. Now we are more in discussions about increasing the process window to get the uptime up. And then you guys must be a perfect fit because if you have a bad uptime, you don't want to mess around with a big cutting station that is supposed to
yeah.
punch the damn thing, and then that one gets stuck, and then your super smart software system with your DC machine of 6,200 ton starts to say that I cannot cast, because the trim press is down. If
Yeah,
you have a torch, you have a torch. Isn't that the
right.
case?
Yeah, I mean, we're bringing a ton of flexibility using plasma. It's not fixed tooling. You mentioned a trim press, and they're down a lot, is what we're hearing, is what we're seeing in the field. So it's that uptime. It's the ability to cut a part that is hot, for example, will speed up the whole process. So and that is one of the benefits that we're able to bring to the customers.
When you mentioned uptime too, I think one of the things that I think about is the maintenance that gigapresses bring to the table and the challenges around maintenance. I think, when you talk about trying to keep a die like that operational, and the maintenance that's revolved around that, I think that brings on a whole new complexity and challenge. And so,
Mm.
maintenance and uptime obviously are two very critical components within the automotive segment. And I think when you add plasma onto it, not only is the uptime improved because of the ease of switching out a torch or even the ease of switching out a power source, but now you can even talk about scalability, and you can even add more robotic arms. You can't. It's you don't really want to add more trim presses or more high pressure die cast machines to a floor to increase your capacities, but it's much easier to add a new robot with a new power source. It's going to be much more practical, much more cost efficient, and it's going to be much easier to scale your production process by moving in that direction. Floor space is not nearly as compromised.
But speaking about scaling up, I mean, if you look at the trim press, all the costs go up with square x times x, because you have width and you have height. And when you start to throw around parts that are 1300 millimeters times 1700 millimeters, it's a lot of steel, it's a lot of machining, it's a lot of things, and that complexity. Again, what I'm trying to say, it's not linear. But if you have a torch, you have a single unit, single entity.
And
So I mean, if you run it for 90
Yeah.
seconds or 110 seconds, it doesn't matter, because the casting cycle is 3 minutes anyway.
Also, if you see the classical trim presses, they get bigger and bigger, and you want to
Exactly.
integrate more and more into the trim press tools. As you want to cut down the machining hours as well, they go up in price exponentially as well with these large gigacastings. So you're not just cutting off the ingate and the overflow system, you're punching holes through the casting, and especially with the thick ingates, so they can feed that long distance. You get also thicker ingates, and you have to support the part better, and just one overflow at the wrong position, everything stops. And that's just mostly the point when the casting process started to run smoothly, and you're back to square one. And I think with a torch from a plasma, then you can add 2, 3, and you can be off axis.
Yeah, absolutely. There's a lot of benefits to plasma. We talked about flexibility a little bit. It's capital cost, it's floor space. Some of these trim presses, the current one's 40-ton trim presses, and they're having to go up as these parts are getting larger and larger and larger. Or if they're going to multi-cavity molds, the trim presses have to get bigger. Or for multi-cavity molds, they often have to have multiple trim presses to keep up. So a trim press, high capital cost, and then you have the tool sets, and there has to be multiple tool sets on hand, and those have to be changed out. They have to be rebuilt, or we're eliminating that. But sometimes it's effective to use plasma and a trim press together. So it's not just eliminating trim presses; it's the collaboration between the two technologies that can also enhance productivity. Where plasma, for example, may cut to near net shape, and a trim press can finish that part. It depends on the part, the design. But one thing I want to say is about the design constraints that design engineers are facing to design around a horizontal or vertical trim press. So with plasma, you can grab the part, you can manipulate the part around a fixed torch, or you can manipulate the torch around the part itself to degate. And again, that goes back to the flexibility. So it's even providing that benefit up front to think differently how they're designing the part and the part gates, and might enhance their designs by using plasma as the preferred degating method versus trim press. Regarding your question about fiber laser, Andy, feel free to jump in. Pretty exciting. So as we were talking, there's a lot of install base of our light industrial systems. There's hundreds of thousands currently in operation. Our heavy industrial, there are tens of thousands currently in operations, but it is largely in industries outside of automotive. If you go to an automotive manufacturer, you'll probably see plasma equipment in their maintenance departments, not necessarily in production. But you're going to see some fiber laser for it, especially for this thin, sheet metal tape applications. So fiber laser, they're familiar with fiber laser. The industry is familiar. We are bringing them up to speed on what plasma technology is, what it can do for them, but there's always a question of, that sounds too good to be true, so we need to prove it. So what we're finding is that versus fiber laser, again, these larger parts, there's going to be a lot of part variance when they're coming out of the mold. The big difference is that fiber laser has to have like a 1 millimeter standoff from the torch to the part itself, where plasma has much greater standoff, around 6 millimeters. Well,
Hmm.
it's more robust. There won't be collisions. If a fiber laser head collides with a part, it's not good. For plasma, it can has enough 6 millimeters. It'll accommodate all those part variances and surface features without colliding. And if you look at cut quality, plasma is superior over fiber laser in these particular applications.
Yeah, I think also that 5 millimeter difference doesn't sound too much. But as we all know, we already had it also in the podcast about geometric variations. When you take such a big part out
Yeah.
of your tool, you're off a few millimeters, and just gravity alone has an
Mhm.
impact on
Yeah.
your distances.
Yeah.
And then if you're bound by 1 millimeter, then you first have to scan the part and then exactly adjust your process. But with 6 millimeters, you're pretty sure you get into it.
Yeah. Yeah. And you can offset, and you can combat that 1 millimeter, but all you're doing is adding cost to the cell, right? So the equipment's more costly, the consumables more costly, the gases required are more costly. Lasers like cleaner environments, and I think operationally, I don't think there really are any gains to what you can receive out of laser. Laser has its place, and there's a lot of places where it can threaten plasma business. But we have seen, and we've challenged laser, and we've had customers challenge us with laser, and the practicality and the ease of use that plasma brings is hard for laser to touch.
But you're not newcomers in automotive. You already have a bunch of installations out there, right? So if I buy a car today, there's a quite
There's
probably
a
that some part is
Yeah.
actually treated with a plasma.
What's the number, Russ? What's the number? You like to say it.
Yeah, so we're estimating at least in last year, at least 1 million cars were cut using a plasma system. So, and a lot of installations globally,
Yeah, yeah, yeah.
dozens,
And
yeah,
you
in
see an
production.
increase in installations, or
Absolutely, especially if you coincide that with the huge growth compounded annual growth rate for high pressure die casting systems, which is leading this trend, and that's well into the upper 40s, is what third parties are saying as is the CAGR for that industry. So we're riding that wave,
but
and
where
I
do you
think
find that? Not in Europe. You find it in the US or Asia or both.
we're seeing it globally. I mean, Asia is certainly leading the
Mhm.
adoption rate. They're 2 to 3 years ahead of us.
Mhm.
In the industry, automotive industry, moving in that direction for sure.
Because if we compare notes here, my strongest market is actually I would say Japan. Not in number of
Hmm.
sales, but in organization and seriousness and how they actually take on to this. Then it's actually the US that they seem to dare to do things in the good old America. And then you have the copy machines in China, and then you have Europe. And Europe, we are a discussion club with a lot of committees, and I mean, trying to bring something new to Europe. I would definitely start in, I don't know what you call it, Dearborn, Chicago, San Francisco, before
Yeah,
even going to
Mhm.
Eurogas in Deutschland.
yeah. So there are innovators, and that we're seeing that in Asia. A lot of innovators, and then there's the early adopters. I think EMEA or Europe, as you're describing, might be late adopters or even laggards. It's just taking
Laggards, yeah.
longer.
Mm.
Mhm.
So we're definitely seeing that, but we have to cross it. The early innovators, they have to jump that chasm to early adopters,
Mm.
and I think that's where we're at now.
Yeah.
Mhm.
Is again back to my statement. It's, oh, that's great. That's too good to be true. Now prove it.
Yeah.
So that's what we're going through, and the automotive industry is like that big ship that is really hard to turn. So, but that ship is definitely turning its rudder and starting to
Yeah,
shift.
yeah, yeah.
I mentioned I mentioned the high CAGR for high pressure die casting. We're hearing that it's 2-year lead times, on
Mm.
this equipment, and they've taken a lot of orders. Now it's just trying to get caught up in all that backlog and get it to the industry, and it's also a shift for the automotive companies who, because again, the trend to larger parts, that logistics, the part size. shipping costs, all that plays into this. So I think automotive manufacturers are looking to bring this in-house, in-line production, building new facilities, and that takes time to build up that infrastructure.
Mhm.
And I think that's what
It
we're
does
seeing
for
now.
sure. But
Yeah.
I mean, if you go to the US, to South Carolina, for example, it's not that super difficult to buy some land close to a car manufacturer. But if you go to the car manufacturing in Wolfsburg in Germany and say,
Mhm.
hello, I want to place a foundry here wall to wall, because I'm going to toss in those gigacastings to the production line, they have a problem. So there is actually physical limitations that I think is hindering Europe as well.
You're absolutely right, and I think, where you've seen the early adopters, it's green space, they're operating from a
Mm.
green space,
Yes,
whereas
yes,
what you're talking about, a lot of the traditional, let's just say, US automakers that are well established, yeah, they've got a lot of real estate already established in Michigan and Indiana and in Ohio, and, to revamp those manufacturing lines is an extremely difficult process with something
yeah.
new like this. So, they really need to understand what it's gonna do for their operations and what they're willing to invest, to make those
Mm.
changes. Because you're right. You can go out to South Carolina, Georgia, and buy up some land and start new. And it's going to be
Yeah,
much easier for you to do that and
yeah.
install those pieces of equipment than as if you have some millions and millions of dollars of existing facility, and now you gotta not only keep production going, but now you got to retool what you're doing.
Mm.
So much different conversations between who the early adopters are and what they have available to them from a manufacturing site.
We call them no legacy customers here at Comtech,
Mm.
Yeah,
and
yeah.
you can tell when you talk to them that sometimes they do stupid things, but they correct these errors and mistakes
Yeah.
within a blink of an eye of a
Yeah.
pig or something. It's really quick, and then you have the old guys in Germany going slow. Anyway,
Mm.
anyhow, uh, in my belief system, cars will be so much cheaper in the future. So kind of would like to hear your take on this, because what we're seeing in Europe, to give the background, set the stage, is that the European car companies mostly are making very expensive cars. We're looking at something starting at I would say 50,000 euros, 45,000 euros, and then upwards to 100, 150,000 euros. And if you look at the car park outside when I do grocery shopping, you can tell people that cannot afford these cars, and all of a sudden we got the BYD starting, Romania, or is it Hungary? We got the Geely factory in Slovakia. Uh, there's a lot of things happening, but end of the day, my belief system is there must be electrical cars that will cost maximum 23,000 euros for the consumer on the street. Do you agree or do you not agree? Yeah.
Yeah, I think they're going to have to, and I think that's what you're going to start to see out of China. I think you're going to start to, right now, when you look at the Teslas of the world, at least here in the U.S., they came in at a very high price point, luxury, but they have slowly, with some of their more recent models, minus the Cybertruck, they have tried to meet more of a market that becomes more
Mm,
affordable. Now, as some of the traditional U.S. automakers who have been making the ICE engines are getting more into the EV market, that's going to force Tesla and others who make luxury vehicles, it's going to force them to operate in that lower price point market. Because when you look at the
mm,
governments and what they're doing and trying to electrify the automotive industry, well, they still have to make it affordable. I mean, and you've
mm,
seen why there's been a little bit of a slowdown in terms of EV production because, well, number one, the infrastructure still needs to get built. That's first
mm,
and foremost. You still need to get buy-in from people to want to move to that. The climates are going to affect the battery performance, and then the affordability of it. So there's a long ways to go, I think, before there's full adoption of what the governments would like to see. But
mm,
yeah, absolutely, they have to come down in price to make these things more affordable to people, and create more buy-in. And so I think as more automotive manufacturers get involved, I think it is going to force more of a price point to compete with some of the Chinese manufacturers,
mm,
as well as some of the U.S. automakers that have production licked, that know how to do production, and can keep their costs down. It's going to force those prices down as well. And companies like Tesla and the margins that they accept today versus what they're going to have to accept in the future when they have more competition is going to look a little bit differently. But they have to become more affordable. To your point.
I agree to that. I think one of the key drivers right now, I mean, a couple key drivers, it's as Andy mentioned, is reducing manufacturing costs. That has to happen. And I think the next driver would be regulations that are occurring right now. So it's the market being influenced by governments saying, hey, your vehicles have to be more fuel efficient, which is great for
Mm.
the environment. But they have to figure out how to do that. So they're trying to go to lighter weight materials, taking one cost out of production, and then making the materials, lighter, safer, and that's happening with this trend to aluminum frames, subframes, and all these aluminum components.
It's interesting. A little bit of not pushback, but I was at a recent convention talking to a tier one supplier to automotive for specifically castings. I mentioned Gigacasting to them, and they didn't push back on it, but they were one of those companies still trying to see how far and how quickly this trend's going to go. They haven't, let's just say, bought into gigacastings, but let's just go and call it mega castings and start to modularize certain parts of the car versus making the car one piece. What happens when the car is in a wreck, or what happens when you crack the front end? You have to replace the whole bottom part of it. So are they moving to larger parts? Yes, but maybe they want to modularize the car a little bit more. And I think that's something that we might be seeing as opposed to, a full underbody or a
Hmm.
front and a rear. Maybe they're going to modularize, the front quarter panel or the rear quarter panel or certain parts of the car, just because when there are accidents, what are you replacing? Because I'm hearing where there is pushback is within the dealerships and the serviceability side of it. Because when there is a collision or when their car does come in for damage and it's happening on the cast, well, how is a dealership going to handle that serviceability aspect of it? Now, Tesla can do it any way they want because they own and manage all of their dealerships here, at least in the US, and I'm assuming
Hmm.
globally. So they can address that within their own dealerships, their own serviceability side of it. But when you get into the independent dealers of the larger automakers here in the US that are independent, then you've got some issues. And then you got to start to address how they operate
Yes.
and how they're going to be trained and how they're going to tackle those issues. So I think castings, it has its place, but I still think the ideas are evolving and companies are still trying to think of the best way to do it for themselves and for the consumer, but also their dealers as well. They're going to have to take care of the car once it's out on the road.
Mentioning the modularity. So if you put some modules, then you also increase the flexibility you need.
Yep.
Then that's basically the perfect entry point for you, just to say, okay, now today we're producing these modules, let's load program ABC, and then we
Exactly.
continue that. And
Mhm.
especially when you see the prices of all these expensive tools, trim presses, and the size go up, that would be quite an impact, I guess.
That's a great point. You're moving away from these fixed assets to more of change the program. You can
Mm.
trim the part.
Mhm.
You don't need to find the trim press and change out the tooling. Great point, Fabian.
I never been in a project where it hasn't been any tool changes between the
Mm.
first sample and the serial. And I've never been in a new product where it hasn't been a massive redesign of some corner of the damn product within a year after launch. Because,
Mm.
we didn't think about it. So why should I buy a trim press for what, 100,000, 200,000 euros, when I know that it will be obsolete more or less 6 months from now? I will do my
Mm.
PPAP sample, those 50, and then I do my other 250 for some pre-series for going up to Sweden at minus 40 degrees. Boom, boom. And then the engineer will say, you know what, we need to add some more material here, and we're pushing these towers at the 15 millimeters. And there you go, then you're wasted. So
Mhm.
I'll buy a torch, I think. I'll probably call Russ if I get into
Uh,
this.
that,
I
that
mean, it
sounds
seems to be
great.
the smart
Now,
thing.
yeah.
Yeah.
Um,
Definitely. But now the German side in me has to come out. And usually, if you put
Yeah,
heat
you
and
cannot hide it.
materials together, now I cannot hide it. But heat and material together, that has an impact on the properties.
Yeah.
And a trim press doesn't put any heat into the material. What's your take on that? Because I think that's a typical questions for
yeah.
most foundries.
That's a typical question, and I said that the statement is, well, that's too good to be true. Now prove it. So we've been proving it. So aluminum materials used for structural automotive is different than, say, a standard like A320. So we've been doing testing with the industry players. We've been doing our own independent testing. And while I'm not the most technical, but so some of our results are, if we look at the heat affected zone around the cut, it's usually between 40 and 80 microns. And what
Mhm.
is the conversion? That's less than 1 millimeter. And what we're finding as we look at, the microstructures is that it's more granular in these areas, and it's actually enhancing the material. So by becoming more granular, it's adding more ductility, more strength to the material around the edges. So it's actually a benefit to plasma cut, is what we found.
I mean, if you look at crack propagation, which is a very fascinating theme, if you go with a plasma, you should have a great reduction of the entry points for a crack propagation.
Yeah, you're the metallurgist here. You're
Yeah.
probably speaking above
I'm
my
just
head
giving you
again.
a sales argument,
Yeah,
guys. So
yeah,
Yeah,
you're
yeah.
I
welcome.
appreciate
Thank you.
that.
Thank you.
Yeah, we appreciate that.
Yeah,
Okay, so
yeah.
tested from backwards and from north to south to left to right, and you're seriously dealing with the gigacastings and the mega castings. How thick can you cut? I mean, if you're looking at the, for example, low pressure die casting, other processes where you actually would like to have a neat cut, maybe 15, 20, 25 millimeters of thickness.
Our sweet spot, as we say, is usually between 2 and 40 millimeters.
Okay.
So our recommended system would be the PowerMax 105 Sync,
Mm,
and that's 105 amp. And that's going to cut most of the gates. So if we look at all the projects, it's probably going to address 90% of those projects and the gate requirements. Again, as you move from 4,000 ton presses to 9,000 is kind of where we're at now in the industry as the largest, to conceptually and some prototypes of 20,000 ton presses. Again, these parts are getting bigger and bigger and bigger. So it's likely going to require some of the gates, especially in the biscuit area,
mm,
where you have a lot thicker gates, and especially if they want to scrap or remove the biscuit first, real close to the big round biscuit, you can go to like an XPR system, XPR 300, or an XPR 460. It'll give you enough amperage to sever the 40 millimeter, or even some larger than that. But we're not
mm.
encountering those yet. Usually, again, between 2 and 40 millimeters is where we're at now in the industry.
Yeah, most of the, like, to Russ's point, most of the runners in the gates, we're not looking at much more than probably 8-9 millimeters. But once you get to those biscuit areas, that's when you start to see, the 1 to 2 inch thick sections where you need to apply more amperage. What's become cool as we've learned more about this industry. I think early on we were really just focused on the Power Max because the thicknesses that we saw probably weren't much more than 17 millimeters. But as we've explored more into this market and talked to more people, that's where we've kind of come into the 40, 50 millimeter thicknesses, primarily as Russ alluded to in the biscuit areas. And scrapping is obviously a big piece of the conversation when you talk to these automakers or even these foundries, because they want to remelt this stuff, they want to recycle the
Mm,
material.
mm,
And when you use mechanical processes, sometimes the pieces are too big, and how do they go down the conveyor belt? And so with plasma, when you do these thicker pieces, quality isn't as important as maybe just getting the part removed so they can go
mm,
into a more of a refined process where you can do more intricate cutting. And the biscuit typically is the first thing to be removed because it is so thick and it is so heavy. And like Russ said, we got the XPR that can pretty much lob off that 50 millimeter piece so they can move into some of the more fine cutting where it's much, much, much thinner. And the Power Max system can take care of that.
If we're looking at a Gigacast part, there are several applications that plasma it can address. It's cutting the gates off. That's the runner, the overflow. It's removing those finger-like protections. It's cutting those off. It's also reducing the size of those so they can be conveyored out, or so they can fit better in, for shipping or fitting back into the oven to remelt it. And then there's feature cutting. So access holes, grommet holes, shock towers. You cut the circle in the shock
mm.
tower. And also I think what is critical, and we have technology called a cartridge that will enable this to be automated, and it's to also a continuous pilot arc. So you don't have to start stop at every feature that needs to be cut. So I think, as you guys know, and the industry understands for sure, is that molds age. There's flashing that comes out.
Yes.
So that can be removed. So as long as plasma is, going around the periphery of that part, the pilot arc is on. So it will automatically start and remove any flashing. And as you know, it's going to be in random areas in each
Yeah.
casted part. So that's again showing the flexibility of plasma to overcome that. That's why we're recommending the PowerMax 105 sync for these applications to our customers. That seems to be the best, well-rounded.
Taking out 1 meter length of flash, how fast can you do 1 meter?
I think when you're talking less than 10 millimeter thicknesses, you're probably around 24, 25, 100 millimeters a minute. You're talking about cycle time with cutting a full gigacast. You're staying within that 45 second cycle time. If you're referencing a kind of a typical size of a gigacasting, we're meeting a cycle time of roughly 45 seconds or under to cut everything.
And that is with one plasma burner, or do you have several of them in use?
That's a great question.
That's a good question.
So it depends on it all depends on the part. Are they cutting hot? What is the size of the part? Do they want to go around the whole periphery of the part and remove all the flashing? Do they have 3 gates? But anyway, so to answer your question, it could be 1 PowerMax, but what we're seeing is 4 to 6 PowerMax syncs in application. Again, it's what production they need to hit.
Another thing that I want to ask you is that you mentioned that you can also cut the biscuit off and these 40, 50 millimeter thick areas, and also the fine cutting. Did you also consider, especially for these gigacastings, you cannot put them in the melting furnace, they're too big to fit through the funnel. So they have to be shredded. Do you also have systems to cut the part in smaller pieces to put into the melting furnace? Because these shredders always break, are heavily expensive, way too loud, and a hazard to operate.
Yeah, I mean, absolutely. That's again back to the flexibility. It's all in the program, right? So you can program it to cut the biscuit off first. So to remove all the weights and then sequence that with one thing that's really cool is that people are removing a lot of the heat and the weight in the biscuit so they can quench and maintain a temperature.
You have an even cool down and you don't get too much distortion.
And the distortion. So it's a ballet, if you will. It's all choreographed. So when you remove the biscuit, when you quench, how many PowerMax? So to meet a 30-second production time, it might move from 2 PowerMax to 4 PowerMax. And the beauty is that they can cut simultaneously and to meet the cycle times. So
Do you have a vision system for these things, so you actually see or revert back, like I don't know, emission, light, reflection, whatever, to a computer somewhere?
We have a vision system for the programming, and that's where we rely on our integrator partners. I mean, they are out there. Our integrators use them. I know that at Hypertherm, I believe in our CTC lab. That's something that we're working on, right, Russ? I know that that's kind of our own part of our own internal solutions, but
absolutely.
Here at Hypertherm, we rely heavily on a channel partner that develops the full solution. And so, to your point, yes, vision, depending on who that channel partner is, has incorporated that into the cell.
Yeah, it could be a vision system that can identify that particular part, the SKU. Usually in these high volume automation lines that it's a dedicated cell. And they'll typically, I shouldn't say typically, we've seen them do a before shot and after shot, just make sure they understand the part dimensions. It sends offsets back to the program, compensates for any significant part variations.
I was thinking about more flash, for example.
You don't need to. That's the beauty. Again, you have a continuous pilot arc that just automatically fires when it sees flash.
You're referring to knowing where the flash is at so that you can trigger the arc
For
to cut it.
example.
Is that what you're saying?
Yeah, for example.
Okay. Yes, and that's the ease of use with plasma. With a laser or other processes, yes, you do need to know exactly where that material starts so that you can send the signal to go. But with plasma, like Russ was referring to, you can think of a pilot arc as essentially when the arc is not initiated, it essentially transfers back to itself or back to the nozzle. So it's like it's always on, if you will. And then once it comes in contact with that part again, like in a welding process, you need to complete that circuit, right? Always have a ground lead that's attached to the part so that electrical circuit is completed. Plasma operates the exact same way. So as long as that pilot arc is initiated and is attaching back to itself at the nozzle, once it gets to that part that's grounded and that electrical circuit is reinitiated, that pilot arc then transfers from itself to the part and makes the cut. That's why with flash, because it is so inconsistent, a pilot arc basically takes that completely out of the equation and you don't have to worry about it.
Good.
Yeah.
Completely different area, gentlemen. You are making this equipment, and then you have partners like robot companies, automation companies, whatever kind of company that make the application. But if I want to meet someone to talk about the torque, do you have an office here in Europe, or how is that organized?
Yeah, there's Hypertherm Europe, we have China, we have
Yeah.
Singapore, we have South America. Most of our operations, our manufacturing operations, our corporate headquarters are out of the United States in New England area, New Hampshire to be specific. It's known as like Plasma Upper Valley. Plasma is where it was created here at Dartmouth at first formed, and Hypertherm was an outcome of that. But yes, we have thousands of distributors globally who are authorized to do service support. So service support should not be a concern for anybody looking to use plasma.
So how does it work? You buy a piece of equipment through your partner. They do a nice assembly. You run your production. Do you wear the stuff out after a year, or how does it work? If you run full-time production with a plasma cutter.
Our power sources, we 3 years, 3 year labor or 3 year warranty on parts and labor for the power source itself. The torches are 1 year warranty, but these power sources operate 100% duty cycle. So I would say that the life of the power source is not a question, specifically from a serviceability aspect of it, and what the duty cycle could handle. But what I'd also say is to have from a maintenance perspective, these are very, let's say, cost effective comparatively speaking to some of the other technologies that are used. And so to have a backup Power Max on hand is not costly whatsoever. And so the plug and play with a new power source, if one does go down, is kind of a no brainer for the maintenance to have. And so these things are going to last years in production.
Well, if I could add to that, these were designed for heavy industry, for the harshest environments as far as humidity, cold temperatures, to work outside in shipyards all over the world in every climate.
And maybe not operated by a brain surgeon either. So
Right. So not brain surgeons running that, very capable people, I will admit. And they have to pick them up. They have to take them to other levels of the ship. Sometimes they'll throw them over the top. They're robust. They're designed. These are the premium in the industry. They're designed to last forever. I've literally seen systems in shipyards 15 to 20 years old still running like new. So yes, they're designed in automotive. It's a clean environment. A lot of preventative maintenance happens in
yeah.
automotive.
Yeah.
So it is, indirectly designed for automotive and the high volume production with duty cycles and robustness for sure.
But I must put the question I hate to have myself. You know it. What's the cost of the thing? I got a 6,000-ton machine. I'm pushing out 20 shots an hour. Other side of that wall, I got the production manager who wants to get these. I need some plasma to take out my casting system and some flash and blah blah blah. Ballpark. What is the price?
List price, published list price that you can find on the internet or on our website for a Power Max 105, which is what we would standardize in this application, is around $6,000, and then the torch to go along with it is roughly 1,000. So with cabling, consumables, power source, you're going to have yourself a plasma system minus the robot, minus the cell and the fixturing. And that's not our expertise. That's our channel partner. But all in from a plasma system perspective, you're going to be up and running for under $7,500 from Hypertherm.
That's amazing. That's basically the shipment costs of your trim tool.
Yeah, exactly. If you look at it, I mean, you probably can go around with a 6-axis robot, and what's that? 52,000 euros. I mean, that's not a big thing, and the fixture for this thing is actually not that expensive either. And you need that robot for your trim press anyway. So that's apples to apples for you. So I mean, that is pretty cheap. Sorry, guys, but it sounds cheap. Not bad quality, but it sounds.
We like inexpensive. We like inexpensive.
Yeah, cost effective would be the European word, I guess.
There we go.
Andy mentioned consumables. I think I may have mentioned it earlier. I think it's important to highlight is that our enabler for automotive is that, traditionally you'll see that there's a 5-piece stack up for the consumables. So Hypertherm has innovated that, and Hypertherm, I failed to mention earlier, but like 10% of our entire organization is R&D only. And this is one of the new innovations to enable automotive. These high volume lines is cartridge is what it's called. And it has built-in data recording capabilities that is beneficial to automotive. You can auto change it on a robot very simply. So no downtime to maintain the press. It just keeps going and going and going, and you quickly change out the consumables as the part is being changed. So I think that is a huge enabler to automotive that I wanted to highlight.
Oh, that's amazing. But if you're a US foundry and you want to get information, where's the best place to get all the information about your products?
Yeah, you can go right to our website. It's Hypertherm Associates, and that's the whole company. You can see Waterjet and Plasma and our software, offline robotic programming software, all of that. And then you can go to hypertherm.com. I think the best way is to contact, if it's castings related, is contact Andy.
Sure. No, my email address is andrew.mulroy@hypertherm.com. And to Russ's point, you can just email me directly and be more than happy to begin the conversation, understand a little bit more about what your needs are, what you're looking for. But Sumya, who wasn't able to make our call today, is our principal engineer, and I'm tied directly into some very smart people that can answer some highly technical questions that we deal with. So absolutely, you can use that email address, and I'd be more than happy to have more of a conversation. We'll attending the NADCA show, the North American Die Casting Association show in Indianapolis, Indiana, the end of September, beginning of October. We'll have a booth there. We'll be basically showcasing this technology. We'll also be presenting a white paper that Sumya Mitra and some of our other engineers have put together. So we'll be presenting that paper as well to talk about the learnings and hopefully educate the industry on what Hypertherm is bringing to it.
That's great. I'll be there, so I'll come by so I can learn this stuff.
Sounds great.
Yeah. It's been a pleasure having you here, gentlemen, and we're looking forward to meet you on the NADCA show in Indianapolis, late September, beginning October, if my calendar is not lying to me. And it's going to be great to see you there, and I hope to see you around in Europe also the years to come here. I think we are sharing pretty many interesting areas and fields here in the die casting industry. So again, thank you very much, Andy and Russ, for being here, and the questions of you listeners out there, text us, email us, send smoke signals, and we try to wrinkle out and do some clarity on it. Thank you.
Thanks so much.
Yep.
Thank you.
Perfect. Then thank you for listening in, especially if you stayed until that end. Why don't you subscribe on the platform you're listening? And then also, again, thank you, Russ and Andy, and also Hypertherm for sponsoring this episode. See you in the next one. Goodbye.
Bye.